our notes today. The goal today is we have vocab. That's basically what we need to cover again. So kind of warn you of that. What I'm gonna hand to you right now is your practice guide. It's front, back, front. And I did not staple them, so you can staple those on your own. I can add on a stapler if you need it. Some people don't like it stapled right away. They like to do it, wait till later. Some people do. It's kind of up to you whether what kind of way you wanted it. But, okay, so there's one. There's two. It's front, back, front. Sorry, I didn't staple them. And I have a stapler if you need it. Again, this is something you will be turning in at the end of the week. So this test is tentatively set for Friday. This is what we'll turn in on Friday. We will work on this in class together because it's the first one, right? That way you're not like stressed out about what you have to do and oh my gosh, this is just more homework. It's really not. This is just to get you kind of alleviate your stress. Like this is what the test will look like. It's going to be the same number of questions. It'll have the same vocab style. It'll have new vocab words because all I did was go through the first chapter. I just went through the chapter and picked out random words that were highlighted in yellow that we've actually covered or we are going to cover because we have a couple of new words today. And then the number of questions will be the exact same. So, let's see. Okay. Did you ever get a practice test? Again, it's front, back, front. I didn't staple them. You can staple them later. I'll hand out the stapler around if you need it. Some people like to wait until the day of. Okay. Again, we're just doing a couple of vocab words today that I said we're going to be adding to do kind of the mix, the list. It's pretty straightforward, so hopefully you kind of have this out in front of you. Practice guide will start today at the second half of class. So the first half is just go through some vocab words. I think it's pretty straightforward, pretty easy. Okay. If you weren't here yesterday, we had a new homework assignment, page 50. That's due on Thursday. That's a couple days from now. Okay. Good news is you don't have school tomorrow, so you do have some time to work on it. If you're at home, take your books home. You have the online version now. As everyone's online version is working, correct? Even though I had to make up just a random name and just give it the password. I couldn't get the name to actually work. I think in those accounts you can change the name. So I think you can change it to like your name with a password. I think you can do that, which is it's in the like a profile setting. You can actually do it. I wouldn't deal with it. So, all right, let's walk through this. Hopefully you have everything out ready to go here. We're just going to take a few notes. In fact, I might get the lights here just so you can have this, and I'll try to zoom in here because I know this is going to be kind of small. It always is. All right, here we go. Okay, first thing, we're going to be talking about polygons. Okay, polygon is a fancy word that we use in geometry for shapes, objects. This is what most people, when they come into geometry, they're like, oh, we're going to learn about the shapes, right? Yeah, we are. It's just that a lot of stuff we cover in here is kind of covering algebra, how to apply it to geometry, how to apply properties. There's a lot more than you think there is to the actual like subject of geometry. So these are the shapes. The goal today is just to intro them, right? To tell you the names. So you're aware of the vocab. Does that make sense? We're not going to do properties or crazy things with it. The next chapter that we go into, then we start the process of learning properties, like how to find area, how to find volume, all that stuff that we have, okay? All right, so I'll give you the definition. This is directly out of the book, the definition of a polygon, and that's it. Polygon, by definition, is composed of quote unquote, many angles. Perfect. That's quote unquote, many angles. Okay. Again, I hate that definition. I hate the definition what the book uses. Many angles. It doesn't tell you anything about the shape. It doesn't tell you how to draw. It just says many angles. Polygon has more specific things. So what I did is I went through a bunch of different math books, a couple years ago, and I kind of picked out the main bullets that all of them shared. Like, what is a polygon by definition other than what your book says? Okay, polygon has to be composed of what they call of coplanar segments. Now, I like going through this, the last section, it reviews a lot of the words we've already discussed. So we're composed of coplanar segments. So they have to be line segments, straight segments with endpoints. And they have to be on coplaning, so they have to be on the same flat surface, on the same plane, coplanar. Okay, that makes more sense. Not just many angles, but now you have segments being connected on a plane, one single plane. Okay, now more specifically than that, when you draw those segments, each segment has to hit two or more other segments. So each segment will be connected to two or more. So if this segment, let me draw this, if this segment right here is connected to two other ones, what's the minimum size this thing can be if this one's connected to two others? If I draw two more segments connected to this, what shape is that?
Triangle.
A triangle. That is the bare minimum shape. We'll see the names here in a minute, the different types of names. But that, to me, makes more sense. Now it's giving you an idea of like the bare minimum thing that you can draw and where it goes from there. So each segment has to be connected to two or more. Now those segments themselves, when you actually connect them at the endpoints, right? They intersect at quote-unquote endpoints, right? Notice I put that in air quotes. The word endpoint has a different word when we start talking about polygons. Instead of just calling them the endpoints, the dots where they cross, we're going to see that vocab at the very end. There's like a word right here that, and I'll put right next to it the word endpoint, so you know instead of calling it an endpoint, there's actually a different term. Okay, then, when you're drawing the segments and they're connected at these endpoints, they cannot be, well, they say, quote unquote, no segment can be, with common endpoints can be collinear with each other. So what that means is that if you're drawing this crazy picture and you have a bunch of segments being connected, right? So here's my shape. You can no longer have something like this, where one of the walls, one of the sides, has sticks that are in a straight line with each other. You can't have straight angles. Yes. So the idea is that they cannot be in a straight line. There has to be a bend in the road. You cannot have straight angles inside of a polygon. That's basically what it's saying. But they have to be connected endpoints. Now, the other reason why they can't be in straight lines with each other and why they have to quote unquote end at the endpoints, at the intersect endpoints, I can't have a shape that looks like this. Okay, pass through. I can't have a shape that looks like that. The reason being, there's two reasons. Number one, those segments can only hit at endpoints. Do you agree that somehow they crossed in the middle? They crossed the middle, okay? And then some people are like, well, Ward, what if that's an endpoint? What if that's an endpoint right there in the middle? And there's a dot here. Well, then it fails the second line. So they have to only touch at the endpoints, and they can't be in straight lines with each other. So that means the bow tie is out of question. You can't have the little butterfly looking picture. Okay, there has to be a flex in the road. There can't be straight lines crossing like that. Okay, it can't be straight. So those are your stipulations. Now, the vocab that I've used when we talked about, like these endpoints. The endpoints are called a vertex. That's a new word, right? A vertex is that common endpoint between segments, or it's the endpoint of a polygon at the corners. It's the points of intersection. So you'll start to call them endpoints, or talk about the vertex or vertices, if we go plural, vertices. And then the walls themselves, like the walls of our shapes, they're called edges or sides. Segments, you'll hear me say that a lot, but usually I think I use the word edge a lot. The edge of the polygon. That's usually my go-to word. So these are the new words. Your book doesn't have any of this. Your book said a polygon is made of many angles, quote unquote. It doesn't tell you how to draw it. There's specific things you have to have. They can't be in straight lines, you have to have endpoints, each segment has to be connected to two or more. These are from a bunch of different things, but they at least share a couple words in common, edges and vertices, vertex. Questions on polygons? Okay, I'll let you write that down now since people are still scrambling. I'll write that down. Okay, we good? Okay, now we're going to get into the specific things about polygons. There's different types of polygons, not just the classifications, the names of them, but the way you draw a picture can be different. Okay, and I'll explain what I'm talking about here in a second. Okay, is everyone good? Make sure you're good. Okay, anyone else? All right, let's move on. All right, so the first type of polygon, not classification, but type when you draw is called convex. Now the book has this crazy definition of what convex is. In fact, here's your definition. I'm obligated to tell you that. That's the definition out of your book. Okay, blah, 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 blah. No line containing the side of a polygon contains points on the interior, blah, blah, blah. It's crap. It's utter crap. It's not a good definition. It doesn't explain anything. In fact, it just is more confusing as you read it. All right, what they're trying to explain, when you draw a convex polygon, is you have a bunch of walls. So I can draw any shape that I want. There you go. Let me just draw a picture. Here is a convex polygon. What they're trying to describe to you on this convex polygon is that imagine you picked two interior points, any 2 points on the inside of the figure. Okay, so pick two. So I'm going to pick, let's go with these two right here. So I picked two interior points. I'm going to draw a segment that connects them, a straight segment, straight line segment that connects those 2 points together. So here it is, and I'm just going to put it as a dashed line so you get the idea that this is imaginary, we don't actually draw it. Right, so here's my segment. Did that line that connected the two dots, did it magically cross the outside of the figure? That's what makes it convex. It did not cross the outside. Now you're probably thinking, how would it cross the outside? How would that even be possible? That would be the other type. That would be what they call, quote unquote, concave. Concave, or what the book says is non-convex, it's actually called concave picture. A concave polygon, here's the crap definition the book says, because I'm obligated to tell you. Line containing the side of the polygon contains points in the interior, whatever. Alright, what concave actually means is that if I were to draw my picture, so I'm going to draw a four-sided figure. Four-sided. Okay, what would a four-sided picture look like?
Square.
Square, rectangle, something like that. I'm going to draw it as a concave picture, not convex, because all the shapes you just told me are convex. I'm going to draw a four-sided figure that doesn't look like a square or rectangle. That's a four-sided figure, believe it or not. It has four walls. It looks like the Star Trek symbol if you're a Trekkie. Okay, but what makes my picture concave, not convex, because all the shapes you guys were saying were convex, is that if I were to pick two interior points in my picture, so I'm going to pick two interior points, I'm just going to put them down here to make this specific so you can see that how this is going to work. Do you agree that my points I pick are on the inside of the figure? They're interior points. I'm going to draw the straight segment that connects them, a straight line segment that connects these 2 points. There's my straight segment connecting them. Do you see that it crossed the outside of the figure? That's what makes it concave. That's what they're trying to say. The line that contains, will contain the side of the polygon, contains points on the interior. It's crossing the outside of the figure as you draw the line connecting the interior points. So this line segment you're drawing, just again, where that's imaginary, it crosses the outside. If it has potential to do it, That's what makes it concave. Here's the easiest definition I can explain to you. Okay, other than drawing it. Does it have like a Pac-Man mouth? Does it have a cave, a cavern, right? A cavity, and like a tooth. If it has a cavity, it's concave. That's the easiest way I can describe it to you. That has a cave, this one doesn't. It doesn't have a dent. It has a dent, it's concave. So here's a picture that always gets people. For some reason, this one gets people. I'm going to draw the T intersection. Okay, like a little block. Concave or convex? Concave. That picture that I just drew with the little T thing is concave. Here's the idea. You pick two interior points. Those points are on the inside. Draw a line. Did that line cross the outside? It's concave. It's got a cavity. It's got a dent. The only way I can make that shape not be a dent, how many walls is that? 1, 2, 3, 4, 5, 6, 7, 8. It's 8-sided. Is draw it like this. Here's an 8-sided polygon that's convex. Stop sign looking thing. There's a difference between convex and concave pictures. There's a difference in properties when you're actually talking about them. So that's something you need to worry about. Like when we start talking about shapes, when we start talking about properties, I need to clarify, is this picture going to have to be convex? Is it concave? Does it work for both? Those are things you got to think about because they obviously have way different properties for insides and outsides. Questions, comments? Okay. Usually once I draw a few, people get the idea. My little common sense thing has like a cavity or a cave or a dent, it's concave. If it's a big fluffy pillow with no dents, then it's convex. All right, let's move on. Now we're going to talk about the classifications and ignore that last part. It's just what I described to you. All right, the classifications. These are all the names that everyone wants to know. This is our last slide of the day. It's our last slide, and then we'll start reviewing. Okay, first type is called a triangle. That is the first type, the first classification of a polygon. In fact, let me zoom. The first type is called a triangle. It's the bare minimum size for a polygon. You have to have, each wall has to be connected to two or more. This is the first shape you can draw. Okay, it can be any type. There's lots of different types of triangles. There's lots of different types. In fact, we can go through the names on Thursday if you want, for the different types. Okay, but triangles have three walls, right? 3 vertices, 3 walls. That's why they actually call it a triangle. Tri meaning 3 angles. It has 3 angles. That's why the definition always falls back to how many angles does it have. What? It's got 3 edges. Okay, the second type. If it has 4 sides, what do you call that? Nope. It's called a quad. Quadrilateral. The ones that everyone's saying, rectangle, square, rhombus, all those shapes, those are the types of quads. Those are specific types. We'll talk about those on Thursday. Quadrilateral. That is a 4-sided figure. It can be any 4-sided figure. It can be the Star Trek symbol I drew earlier. It doesn't always have to be a square or rectangle. It can be very odd shaped. It doesn't have to be symmetrical. There's other types. There's like 6, 7 different types of quads. Anything 4. Quad means 4. Quad and laterals are walls. So it has 4 laterals, 4 sides. Pentagon is the 5th type. I guess number 3, but it's got 5 walls. Maybe I should put it that way. It's the 3rd type, but it's got 5 walls. The Pentagon building in Virginia, that's the government building, right? It's got 5 walls to it. In fact, what makes that building so special is because normal people don't build a house with 5 exterior walls like that. You know, the outside profile of the house has 5 edges. If you look on a house like side on, you know, the side profile of the house kind of has 5 walls, right? That's what everyone thinks is a pentagon. But what makes the Pentagon building special is that's the top aerial view. So you're actually seeing the outside walls. The inner court is actually 5 walls. Everything in the building is symmetrical. A lot of people in the building actually say you can get lost pretty easy because everything looks the same when you round a corner. Like you don't know which bend you're at, which way you're facing. And they do that on purpose, in case there's, a terror stack or something. But the interesting thing about the building is it's actually called a regular pentagon. Now I want you to write this word down. This can be on the side of your notes. The word regular in geometry has a different definition than you think it does. Most people, when they hear the word regular, they think ordinary. Like you're regular, you're just ordinary, you're normal, right? That's regular. Not in geometry. Geometry, regular is the most special type of figure. To be regular, like a regular pentagon, to be a regular quadrilateral, to be a regular other shape we're about to see in a minute, every wall has to be the exact same size. So all walls are equal. All edges are equal. All edges are congruent. Okay, that's also called equilateral, if you don't know. That's the term equilateral. All walls are equal. Meaning equal, and laterals are sides. And so that's what makes it regular. All the walls are the same, and all angles are equal. We've been talking a lot about angles. All angles are congruent. This is the congruency symbol. It's a little equal sign with a little squiggly above it, right? All angles are congruent. Well, that means it's equiangular. Equiangular. That's what makes a picture regular. Not every shape is going to be regular. That's a rare feat when that happens. But the angles in the corners are all the same and the walls are the same. Questions with the word regular. That building just happens to be, so it's a regular pentagon. Questions about those? Okay. Get rid of it. Yeah, okay. Next shape. Hexagon. How I remember what a hexagon is, it has an X in it, right? It's an X for hexagon. What number has an X in it? 6 sides. 6 sides is that shape. Let me zoom out a little bit. Hexagon has 6 sides. You're actually looking here, that is not a stop sign, by the way. That shape right here, that's a hexagon. It's got 6 walls to it. That would be like a protein crystal, bacterial crystal. They come in those shapes. Honeycomb come in this. And these will build their hive. It's very structurally sound. Another hexagon shape. That shape I actually have picked out is actually regular. That shape, so that's a regular hexagon. All the walls are the same size. All the angles are the same. They don't always have to be, but I just picked out a profile of a honeycomb. That's a hexagon. The 7th word, or I should say the 5th term, but the 7th sided figure is called a heptagon or a septagon. It actually has 2 different definitions, Latin versus Roman. So I'll accept either one, heptagon or septagon. I think the book for you guys uses heptagon. I think your Chromebooks will actually, if you type in septagon, it'll autocorrect it for you because it knows it's the same word as heptagon. So heptagon or septagon. 7-sided. I don't have a picture of that one. Just draw something with 7 walls. The next one is called an octagon. Octa meaning 8, right? Octagon. Octagon is the stop sign. It's got 8 walls, top, bottom, right, left, and then the diagonals. Most of these polygons are used in DOT services for like warning signs, like traffic warning signs are in triangles. Informational signs are always rectangular in shape, quads of some form. They can be a rectangle, it can be a square, but that's informational stuff like mileage or speed. Warnings are always triangles, like warning, do not enter, no passing, like those are warnings. Anything specific will be in like one of these other shapes, like the stop sign is unique, everyone can recognize the stop sign. That's probably one of the hardest parts about the driving test that you ever have to take. Not the driving test, but the actual like written test that you take for like your license or your permit. You have to do that part on the test where they give you all this, like the signs, and they take all the words out. And you have to figure out like what is that sign, what is it supposed to be. That's the worst part of the test, because half those signs you've never seen in your life if you live in Iowa. So, but they have to get you prepared for it. So if you go somewhere else, you know what that sign is actually telling you to do. The octagon is pretty infamous, 8 sides. Okay, the 9-sided polygon. Now this is kind of funny. The book says it's called a 9-gon. Some textbooks say that. It actually has a more specific name. It's actually called a nonagon. A nonagon. That's the word I'm going to use. Nonagon. Any shape, you can actually just say that, like the side, like so, a 9-gon, a 3-gon, a 4-gon, a 5-gon, but they have specific names, so I use the specific ones. So pentagon, hexagon, so nonagon is 9, that's the Latin form of it. 10 is called a decagon. Deca is like the metric word for 10. That's why the metric system always has like decameters or decimeters, they're always in tens. So 10 sided, I don't have to picture them. 11-sided polygon is called an 11-gon, or more specifically, a hendecagon. Hendecagon, decagon is 10, right? Hen means one more than 10. So hendecagon. And then the final one I'm going to give you, the 10th one today, there's more, obviously, but the final one I'm going to give you today, the 10th one today, is a 12-sided figure, and they call it a dodecagon. Do is 2, like do, re, mi, fa, sol, la, ti, do, right? The song that everyone knows. Do is 2, and dec is 10, so 2 more than 10. That's how I think of it. So 12. Anything past dodecagon, they don't have names for them anymore. They call them 13-gon, 14-gon, 15-gon, 1,000-gon. You can just have more walls to it. Okay, questions, comments about the shapes. Thursday we'll continue on with this. Okay, we'll continue on with the naming system. Because I want to go into the specific types of triangles and quads, because a lot of you were saying like squares and rectangles. And most people know the different types of triangles. It's kind of nice to see those names. It's just a bunch of vocab. Questions at all? Okay. Take out your practice guide. So if you didn't get one, have that out. It should be front, back, front. So it should be 2 pages. I just didn't staple them together. All right. Okay. Let's get rid of this. Let's talk about your practice guide. Test is tentatively set for Friday. We still got to get through the review, so. Alright, so let me hit the lights here. Actually, maybe I'll put the lights off. It might be easier to see this without the lights on. Alright, so you got your practice guide.
You want me to take my test on Monday then?
Yeah, if you're not here. Yeah, no worries. Okay, so practice test, chapter 1 here. The most common mistake, or the most common thing that people have a huge issue with is the vocab. I don't know why. Vocab, I think, is probably the easiest part, but people hate it with a fiery passion. I give you the word bank. It's right here. Here's your word bank. You know, it's got a ton of words in it. All the words in the chapter, you should recognize them. I use them quite a bit. It's got all the definitions. And all I need to do is write the words down here. Don't do some weird letter number system. I want you to actually write the words in these little blanks. Now, if you write really big, like that's like impossible for you. You have space over here, just make it bigger. Write the word down. I'll try to give you more space on the next test, but that's what you can expect. Now on this test, look how many words there are, and look how many spaces there are. I think there might be one maybe extra word, maybe one extra word. It's almost pretty even. Every test we go to, there'll be more words in the word bank and less vocab definitions. So now it gets harder and harder because now you got to know which word is which. You can't just guess or fill it in. Do we do official count? Is it 1 for 1 or is it off by 1? I think it's off by 1. I think there's like one word you won't use. So that's the first test. Second test is usually 2 words you won't use. Third test, there's 3 words you won't use. That sort of thing. I think there's only one test out throughout the whole entire year. Only one test you'll have to use a word more than once. Everything else is like one word you use once. Once you use it, cross it out, you're good to go. And remember, I want you to pick the best word possible. Okay, my goal today is to get through the vocab. I want to get through the vocab before we're done today. Does that make sense? Because that's like, it's going to take us the most time. Everything else is really quick. Short answer, formulas. I'll have the formulas written on the board probably on Thursday. They'll be over there and in the back and over here. So I'll have all the formulas you're gonna need. They'll be on test day. Okay, let's go through the first one. What I'm gonna do, I think that maybe this is the easiest way to do this, is I'm just gonna go through the word bank here off to the side. Where's my cursor at? There it is. I'm gonna just go through the word bank, and I'm just gonna say those definitions out loud, and then you can go find them. So I'm just gonna start with point, work my way down, say the definition out loud. You go find where it's at and write it down, and help each other out if you're sitting in your little pods. Does that make sense? Because I think maybe that's the easiest way to do it. Now again, remember, these aren't all the vocab words from the chapter. I went through the book and just flipped through the pages and I just picked ones at random. That's what I do for the test. I go through chapter 1, pick words at random, and I just make sure that we have covered it. I'm not picking words that we've never covered, but I'm just throwing those out there, okay? All right, let's go through this. And there's a couple words on here we need to talk about, and that's something we're going to discuss on Thursday. We haven't got to some of those words because we have to talk about the shapes and stuff still. So there's a couple words that we're going to get to. Okay, point. It's a position or a location in space labeled with a capital letter. A position in space labeled with a capital letter. That's the word point. Go find it, write the word down in that little blank. Second word. Yeah, I'm going quick. You're going to have to help each other out. The word plane is a limitless flat surface that contains no edges, right? So it's a limitless flat surface that extends in all directions, maybe. That's the best way to put it. So that's what the word limitless is. That's a plane. That's on the list. Hopefully you're finding it, help each other out. Okay, coplanar. It's points that are contained on the same flat surface. Geometric figures contained on the same flat surface. That's coplanar. It can be anything. So that's coplanar, on the same flat surface. Geometric shapes, figures. Ray is a type of line that contains one endpoint and extends in one direction. So it goes with the line that's in one direction, but it has an endpoint on the other. Maybe that's the best way to put it. That's a ray. Space is the set of all points. Space is the set of all points. That's space. Congruent, equal in size, shape, and measure. Two objects that are equal in size, shape, and measure are congruent to each other. Again, help each other out. That's the word congruent. Distance is the length between objects. That's distance. It's the length between 2 points. A segment bisector is an actual geometric figure that intersects an object at its center point. It basically breaks an object into two equal parts. It can be anything. An actual like bisector, segment bisector is like it's a line, ray, or segment or plane that intersects an object in half. It can be any object, but it's cutting something in half. It's a segment bisector. Opposite rays. Opposite rays are two rays that face in opposite directions. They form 180 degrees. It's the object that they just have to point in opposite directions, basically. It's a line formed by two geometric objects. That's an opposite ray. Edge is the side of a polygon. We talked about that today. That was one of our new words. Edge. Side of a polygon. Interior points. Points contained on the inside of a geometric figure. Points on the inside of a geometric figure. Or points that lie on the inside of an angle, or rays of an angle. that's interior points. They just have to be on the inside. Degree is a form of measurement of an angle. That's how you measure an angle. It's labeled as a degree. Acute angles, or angles that are measured to be between 0 and 90 degrees. They have to be less than 90 degrees to be acute. Less than 90 degrees. Obtuse is anything between 90.001 and 179.9 repeating. That's obtuse. Adjacent angles are angles that are side by side. They share a vertex and a ray, a common vertex and a ray. That's adjacent angles. Vertical angles are angles that are formed by the intersection of lines. That's vertical. It's angles formed by the intersection of lines. Straight lines. Supplementary. It's two angles whose sum is exactly 180. The sum of two angles is exactly 180. Convex, a figure where no interior points connected with a segment crosses the edge of the type of polygon. That's a stupid book definition. I had to put it on there. I had to use the book definition. No interior points connecting the segment across the edge of the type of polygon. That's convex. Equiangular. It's all the angles that are congruent. A geometric figure with all angles equal. That's equiangular. Circumference is the distance around a circle. It's a word for the perimeter of a circle. We use circumference. I'm going to explain that. It's a new word that we're going to talk about on Thursday. So we haven't got there yet. Perimeter is the distance around a geometric figure, not a circle. It's the distance around a geometric figure. And a regular polygon is an object that has congruent sides and congruent angles. Everything is the same. All edges and all angles are congruent. Alright, questions about any of those? Is there any ones that you didn't quite get, that you had a blank next to? You're like, I didn't get that one. I don't have, all angles whose measure is less than 90. Or is there any blanks you didn't get? You can help each other out. Might be like a word or two that we're not using here. I'm almost guaranteed one of them isn't used. What's the one word we didn't use?
Supplementary.
Supplementary. Okay. Now remember, some of these words are free game for the test. They are. There's some words that are in the book that I didn't choose. Those could be on the test, because when I go through the test, I flip through the chapter, I pick at random again. So some of these could be on there, because it's random. To pick the page, I put some of the words on there. There are used book definitions. You have the dictionary in the back of your book, so you need to be looking through chapter 1 and seeing the words. Okay, tomorrow we'll start doing all the stuff below. Make sense? Some of those pictures get a little faded. It's nice to see it on the marker board. Okay, you have homework. It's due on Thursday, page 50. Take your books home. You don't have school tomorrow. You got to take your book home tonight. Work on it. If you're missing any work from me, I'll email you tonight to let you know, like, hey, you're missing this page. Get it turned in. Or maybe you want to redo something. So, handwriting stuff.
Congruent and I think obtuse.
All right, there you go. You can get obtuse.
No, I got that.
Okay.
I'm going to try and get my homework today.
What was the definition?